Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. In this video, I would like to explaining in details about basics of metal forming processes and mainly focusing onto a cold working process and hot working process. So let us start with the basics. So introduction to metal forming processes. So in that case of the metal forming processes, that will be also known as a mechanical working processes. So in that case of the metal forming processes, there is no any kind of cutting, there is no any kind of joining, but with the help of mechanical working, you will converting into desired shape and size. So you can say that as a primarily shaping processes. So basically subjected to the mechanical forces that will be having a permanent deformation and it will be having a desired shape and size. So that will be depends upon the mass of the metals as well as the alloys. So how much force is required, according to that it will be converting into different size and shapes. Metal forming is possible in case of such metals or alloys which will be having a sufficient malleability and ductility. So these two properties are essential to work with the metal forming processes. If the hardness that will be present into the material, so it will be having a difficulties or there is no any kind of scope to converting into desired shape and size. So your material must be, it will be malleable or ductile. Mechanical working requires that the material may undergo plastic deformation during its processes. So metal forming processes technically it will be defining as a plastic deformation of the raw material that will be used to converting into desired shape and size. Frequently, the workpiece material is not sufficiently malleable or ductile at ordinary room temperatures, but maybe that will be becoming when that will be heated. So by the application of the heat, each and every material it will be softened, and that soft phase of the material at elevated temperature, that will be easiest way to converting into desired shape and size with the forming process. So basically metal forming processes that will be having basically two types: hot working process and cold working processes. So there is the basic operations that we already discussed, both hot and cold metal forming operations. Now we will discussing with the hot working process. So in case of the hot working process, basically it will be work at above the recrystallization temperature of the metal. So it will be known as a hot working process. Set above the recrystallization temperature, any kind of material or you can say metal that will be having a soft phase. So according to that soft phase in nature, so it will be easiest process to converting into desired shape and size. Some metals such as lead, tin have a low recrystallization temperature and can be hot work even at the room temperature, but most commercial metals require some heatings in nature. After this, if the hot working is completed just above the recrystallization temperature, then the resultant grain size would be finer. So the hot working it will be the requirement of the less amount of force. So in case of the hot working process, metal should be heated to such a temperature below its solidus temperature line. The different kind of effect of hot working on the mechanical properties of the metal. So basically this process is generally performed on a metal held at such a temperature that the metal does not work harden. For a few metals, as per examples, lead and tin can be not hot work at the room temperature, but hot working produce the same net result on a metal as a cold working and annealing process. Then after, in case of the hot working process, the compositions irregularities are ignored out and non-metallic impurities are broken up into the small, relatively harmless fragments which are uniformly dispersed throughout the metal instead of being concentrated in a large stress raising metalworking masses. So, in case of the hot working process, it will be utilization of rolling process refine the grain structure. So according to its structure, it will be having a different properties. So the surface finish of the hot work metal is not nearly good as with the cold working process because of the oxidations and scalings. So in case of the heating of the metals, it always forms an oxide onto that layer, and due to that formation of the oxides onto that layer, it will be known as a scaling onto the metal. So due to that scaling, if you work with the rolling or forging, so the outer surface that will be damaged, so the dimensional accuracy is not be performing well, or can say achieved with the help of hot working process. So in case of the cold working process, you will be get good dimensional accuracy components. So there is the difficulties for the hot working process. So too high a temperature may be cause phase change and overheat steels, whereas too low temperature may result in excessive work hardening. So in that case of the hot working process, there will be the main challenge. You should maintain that temperature according to your selected compositions, not to overheat, not to lower heat, that kind of requirements. So the control that will be essential part for the hot working processes. Defects in the metal such as blowholes, internal porosity and cracks get removed or welded up during the hot working processes. Because the scaling is being formed, an oxide that will be also formed during the heating of the metallic materials. During the hot working, self-annealing occurs and recrystallization takes place immediately following plastic deformations. These self-annealing actions prevents the hardening and loss of ductility into the materials. Some of the advantages, or you can say merits, of the hot working process: as a material is above the recrystallization temperature, any amount of working can be imparted since there is no strain hardening taking place into the materials. At the high temperatures, material would have high amount of ductility and therefore there is no limit on the amount of hot working that can be done on a material. Even the brittle materials can be hot rolled nowadays. In the hot working process, the grain structure of the metal is refined and thus the mechanical properties as being improved for these hot working processes. Porosity of the metal is considerably minimized with the hot working processes. If the process is properly carried out, you should control the temperatures so hot work does not affect tensile strength, hardness and corrosion resistance, etc. Since the shear strength gets reduced at a higher temperature, this process requires much less force to achieve necessary deformations. So if you provide less amount of the force to converting my raw material into desired shape and size with the help of hot working process, larger deformations can be accomplished more rapidly as the metal is in plastic state. So it will be having a good deformation rate, or can say easily converting into desired shape and size with the help of hot working process. Concentrated impurities, if any, into the metal are disintegrated and distributed throughout the metal with the help of hot working process. Now some of the demerits of the hot working process, or you can say disadvantages. Due to the temperature in hot working, rapid oxidations or scale formations and surface de-carburization take place on a metal surface, leading to poor surface finish and loss of the material. So you can say that you will having difficulties to achieving the dimensional accuracy, or you can say physical properties with the help of hot working process. So you should take care with the hot working process. So always work with the over dimensions. on account of the loss of the carbon from the surface of the steel piece being worked and surface layer loses its strength. Some metals cannot be hot worked because of their brittleness at the higher temperatures. Because of the thermal expansion of the metals, the dimensional accuracy in hot working process is difficult to achieve, that we already discussing. The process involves excessive expenditure on account of high cost of the toolings required. So the basic difference of the hot working and cold working. So whatever the merits of the hot working, that will be the demerits of the cold working process, and whatever the demerits of the hot working, that will be the merits of the cold working. So if you differentiate both the process hot working and cold working, so in case of the hot working process, that will be a plastically deformation of the metal above the metal's recrystallization temperature. And in case of the cold working, or can say work hardening, is the process of the strengthening of the metal by plastic deformation at a temperature below the recrystallization temperature. So temperature plays a vital role to getting the hot working process and cold working process. So you should remember the recrystallization temperature. Above, that means hot working, and below, that means cold working. In case of the hot working process, no internal and residual stresses built up into the metals, but in case of the cold working, internal and residual stresses built up into the metal, and these residual stresses you need to removing from your components, because that will be deteriorating the mechanical properties and durability of the metals. Deformations of the metals and its recovery occur simultaneously in hot working process, where no considerable metal recovery take place in the cold working process. Cracks or pores can be removed into the hot working process because of the heating and then pressing or forging or any kind of operations. You should remove that. But in case of the crack propagates and new cracks are formed into the cold working process. In case of the hot working process, uniformity of the metals is very high after the hot working, but in case of the cold working process, uniformity of the metal is low. So I hope you can understand these basics about the metal forming process. If you like this, then subscribe and share. Thank you so much.